Hello, today we are talking about the atom and how it came to be what it is today. Now you're probably asking yourself this question: why are atoms important? Atoms are important because they are the basic building blocks of all matter. The body is made up of billions of atoms. All elements are made up of atoms. They're in foods, drinks, and gases. Atoms and matter are everywhere and can be found in mostly everything. It was not until around 460 BC that a Greek philosopher named Democritus developed the idea of the atom. He asked himself this question: if you have a piece of matter and you break it in half, and you break it in half again, and then again, how many breaks would you have to do until you could go no farther? In the end, he figured that it would end up into a single small piece of matter, and he named this piece of matter the atom. Democritus' atomic model was a rounded sphere, just like the one I have here. In this solid sphere, there was no electrons, protons, or neutrons. And this idea will go on to lead many other scientists to further the research Democritus already put into this. In his theory, he had 5 beliefs on it. 1. All matter consists of invisible particles. These we'll call atoms. 2. Atoms are indestructible, meaning if you hit them with a hammer, they're not going to break. 3. Atoms are solid, but cannot be seen with the naked eye. 4. Atoms are homogeneous. And 5. Atoms can differ in their size, shape, mass, position, and arrangement in the things they actually make up. In solids, Democritus believed there were small and pointy atoms, and liquids, large, rounded ones. And in oils, he believed they were small in order for them to easily pass from each other, giving oils the characteristics that it has. After Democritus came an English school teacher who performed countless experiments on atoms. He viewed these atoms as tiny, small, solid balls. In Dalton's countless experiments, he was able to formulate a theory on them, which included 1. Atoms are tiny, invisible particles. 2. Atoms of one element are all the same. 3. Atoms of different elements are different. And 4. Compounds are formed by combining different atoms. And after John Dalton came a man by the name of J.J. Thomson. In a series of experiments designed to study the nature of electric discharge in cathode rays, he was able to discover the electron. His experiments demonstrated that cathode rays could be deflected by a magnetic field and that their negative charge wasn't a separate phenomenon. And he proved that atoms are made up of even smaller things. And since there was electrons in the atoms, in order to keep them neutral, there would need to be somewhat of a positive charge as well, protons. And he was able to redesign what the model looked like at the time. He discovered the plum pudding model. He described it as a positive dough with negative charges inside. And after J.J. Thomson came a man by the name of Ernest Rutherford. In his experiment, he took a piece of gold foil and emitted beams of alpha particles through it. He observed that most of the alpha particles went directly through, but some of the alpha particles would be deflected or bent. By seeing this, Rutherford was able to conclude that atoms are made up of mostly empty space, which allowed most particles to go directly through, and that a small positive nucleus was needed in order to deflect the positive alpha particles going into the atoms. With these conclusions, he was able to redesign what the atom looked like at the time, just like the one I had drew here, with a small positive nucleus and a ball of mostly empty space with electrons somewhere in it. While working with Rutherford, Chadwick was able to discover neutrons. In his experiment, he discovered particles with no charge in the atom. In his experiment, he was bombarding beryllium atoms with alpha particles, and an unknown revolution was produced. The radiation was interpreted as being composed of a particle with a neutral electric charge that contained a similar mass to that of a proton. Bohr was able to improve on Rutherford's models. He proposed that electrons move around in the nucleus and not just stay still, in specific layers or shells, and that every atom has a specific or max number of these shells. He was able to discover this by measuring the radiation emitted by electrons going up in energy levels, and by doing math and calculations, he was able to get specific numbers for them. Bohr's atomic theory was that electrons traveled in circular orbits. Orbits have a quantified sizes and energies, and energy is emitted when an electron goes from a higher energy level to one of a lower energy level. And this can be calculated by using the quantum theory. And today we have the modern model. After the work of countless other scientists, the modern model, or the quantum mechanical model, was formed. The new model of the atom shows that electrons move around in the atom in an electron cloud, just like the one I drew here. Now time for a quick review. First was John Dalton. He believed atoms were tiny small balls in all matter. Thomson. While working with a cathode ray, he discovered electrons, and in order for them to remain neutral, they would need a positive charge as well. Rutherford. In his gold foil experiment, he discovered that atoms are mostly empty space with a dense positive nucleus. Bohr discovered shells in atoms for electrons by measuring energy release from atoms. Then we get to the modern one. As well as having shells, atoms also have an electron cloud.